The data that does not have any context, that doesn't have any real life uses, is useless, right? Or at least is useless for us right now. Maybe we do not understand, maybe we do not have context for that. But as soon as we have some context for the data, what this data means, there is some meaning we can extract out of it. Whether it gives us any benefit or not, it's not random, it's information. If it tells you anything, useful, useless, whatever, it tells you something, then it becomes information, right? And usually, this is a question that is very important for anybody who's starting out. Right now, we have been working for several years in the data field, so it's easy for us to forget as well. But we think in terms of like business value of it, right? That's the difference. We have to think in terms of whether it makes sense or not, right? So values used to record information, often representing entities that have one or more attributes. That's the most terrible definition of data I've ever heard in my life. But Microsoft tends to do that. So the thing is, when we are talking about data, values used to record information. Any information that you want to record, it has to be data has to be a precursor of it. But they just assume that it would lead to some information. That's why it's not a good definition. There's three types of data that we use in context of Microsoft Azure, or that we use in context of data manipulation or data engineering. It's structured, semi-structured, unstructured. Unstructured data is like anything. Like it could be random files. It doesn't have any structure to it. It just like written words, written paragraphs are unstructured. Anything that does not have a structure to it, which unstructured, if you're talking about, we need to talk about structure as well. Structured data has like a set structure, probably in form of a table. There would be rows, there would be columns, and the data would be more or less in a homogenized form, right? It would be expected that wherever there's ID given, you know that there are integer values here, you know that there are character values here, you know that there are uh, um, basically, you know, the price is going to be in form of a price, right? It's not going to be XYZ randomly here, right? Address is going to look like an address, email is going to look like an email. It holds that sort of a tabular structure to it, and that's what makes it uh, structured in nature. Okay, unstructured is which does not follow it. What does semi-structured means? That's a really good question. I enjoy asking in my trainings. So semi-structured data is that it's not very rigid. It's not very rigid in nature. It's not as rigid as structured data. Structured data, you know exactly what's going to come into the next field, or what data type is going to be. At least data type you're going to know, or at least you can expect the type of data that you're going to see. Data type and the type of data, two different things, by the way. You're going to be able to see and you're going to be able to predict in this, right? Because it's a very set structure. In case of unstructured would mean that it's in case of semi-structured, it means that it's not super unstructured. There is still some rules to it. There is still a way or method of writing to it that it makes sense, but it's not in a very strict structured method or very strict structured manner. Things like JSON is one of the best examples, to be honest with you, right? You know how to write JSON. Um, like a lot of coding languages would be part of like semi-structured data, right? Because there is a structure to it, there is a syntax to it, there is a spacing to it. You know what exactly is going to get contained in something like this. So let's see, like this contact type number, type address. So it's like loosely, it's still structured, but it's loosely structured, like within JSON, right? So usually semi-structured data is called semi-structured because it can be used in both of these categories. Depending upon what kind of use case we have, you can use it as a structured form, or you can transform it into a structured form, or you can use it as an unstructured file. So you're like dead in the middle of that situation. How data is stored? There are several formats that you can store it in, right? First of all, you can store it as files, right? Any type of files. It can be a Word file, it can be a delimited TXT, it can be a JSON file, JavaScript object notation. Another example of a semi-structured file type would be XML, right? CSV technically is structured. People often call it as semi-structured, or it's not semi-structured. It's technically structured still. Then there is Blob. Any major file size, like it's stored as binaries, binary large object based storage is Blob. You can see other formats like Orc, Avro, Parquet. Um, if you're in the Microsoft space, I believe that you use Parquet a lot. And over the period of years and across continents, I've seen this difference as well, that different countries and different continents pronounce Parquet differently. It's like Parke, pronounced here in North America, Parquet, but I've seen Parquet as well. So whatever you say, it works. As long as you understand, doesn't matter how you say it. Okay. So that's how the data would be stored. This is for a semi-structured and unstructured format. Store it as a file. Store it as a file, store it inside of a blob container, store it inside of a ADLS, store it inside of like a data lake. Not data lake, store it inside of a lake house. Fair enough. Feel free. Wherever you want to store it, just store it. Else, you can use databases. You can use relational databases where one table has relationship with another table with another table. It's like just do as a relational database, or you can do it as a non-relational database where you have like a key value table. Based on that, you have uh, you can have like various different documentation forms, and you can have like columns. You can non-relational databases again would make sense, and we are going to go a little deeper into why you would want to use non-relational databases in certain cases. But most of our use cases would be with the relational databases that we see here, right? So you may have seen tables within databases, and I wanted to discuss this real quick. How is a database different from a file? It's fairly simple. Database is very structured. Database is very large. Database keeps the information in form of tables. Those tables could be related to each other. The columns within those tables could be related to each other, right? Now, there's a lot of scope for ETL based practices when we are talking about databases, right? Fair enough. And the thing is, there is a term that's commonly used within our space, within our space. So there's like databases. Within the database, there's a schema. What's a schema inside of a database? Anyone? Pretty basic. Please feel free to try it out. What's a schema? Anyone? Basically, this is the scheme of data that we have technically. You want to break it down departmentally, you want to break it down application wise, fair enough. But the thing is that this table the data in this table is in this particular format, and it is going to use for XYZ application. But here, like that's a standard, right? And within the tables itself, you would see certain times something would be written as D table and F table. And I'm and if you do not know, that's okay. And some people might know, some might not know, because it differs from organization to organization as well sometimes. So have you heard of these terms, D table and F table? And the thing is that within the dimension table, it talks about the categorization of data, or like what kind of data it is. Like fact table would have the actual data, right? If the dimension table is about, if the D table is about, let's say, how many, well, this table is about that users that are going to stay in the hotel, right? Or the people that are going to stay in the hotel. That's how it's categorized. The F table for that stay is going to be exactly the people who stayed in that, right? So usually whenever you're trying to query, if anybody is kind of new to this, if you see an F table and you try to query it, you want to do a select star from F table and whatever, like whatever F table that you see. Don't do it. F tables are huge. You'll end up just going into iterations and iterations and iterations of select star. It's like if you're doing it via SSMS, it will take you forever. It's a good practice to do like a select top 10 star, top 15 star. If you're working on an F table, on a D table, you can just load it, the whole thing, right? So it's straightforward, but like a good thing to know, right? But yeah, but that's perfect. Dimension tables are talking about relationships. Fact tables are like hard code facts, numbers, data itself. So fact tables are that. So anybody who's been in a migration project, anybody who has done any migrations in the past, you would know that copy activities on fact tables are, they are painful if they don't go right. Right? Maybe you're not using the proper method or whatever, but they don't go right sometimes. So whenever the data is stored in the database, it is optimized for OLTP. Now there are two different types of things: OLAP and OLTP. Right. Data stored in the database is optimized for online transaction. So whenever you want to do more transactions from the database exists and you want to do like concurrent transactions with it, right? Let's say it's a bank and then there are transactions that are getting loaded. Fair enough. That's a transactional database. If it's a database that's storing sensor data, right, for a heat sensor, for a pressure sensor, for whatever, like depending upon what your use case is, that's transactional. Whenever the updates are going to happen, then this T is very important. Transactional, online transactional processing, mixed of read and write activities are going to happen on that. Then you are doing an OLTP function, right? OLTP is used for something called as databases. Okay. Now, what if you wanted to set up analytics on top of this? You wanted to set up some analytics on top of this. You want to create a report based on whatever metrics there are, like, and we'll go into specific examples later as well. You want to create a report based on like difference in pressure sensors throughout the day, based on temperatures, based on timings, right, or whatever. You want to create that Power BI report. Fair enough. Are you going to create it directly from a database? Yes, you could, but it would have like two problems. One, it would be slow to load because the database is actually being used and it's actually being updated. So the report generation might take a little bit of time because it's real time. It's RT reporting, real time reporting. If you take your Power BI report and link it directly to the database, fair enough. Problem number two, because it's a transactional thing, database transactions are already going on, and then you have a report that's also trying to transact with the database, trying to read the information, trying to query the database, fetch it, trying to fetch the values, make sense out of it. You may end up bringing the performance of the database down. You want the performance to just be keep on going. So for analytics, for the A activities, analytic activities, you do not directly go to the database. You do not directly go to the database. We'll figure out what we do, but we do not do this. So OLTP activities, whenever you see, they are technically, hey, database is working, database is on something, right? Asset transactions are going on. Asset means atomicity, consistency, isolation, and durability, right? Now, what are these? Each transaction is considered as a single unit of work. Either that single unit fails or it succeeds, right? Like maybe it's a copy activity, so atomicity. Consistency. Transactions can take the data in the database from one valid state to another. Isolation, one concurrent transactions cannot interfere with one another. And durability, when the transaction has succeeded, data changes are persisted in the database, they don't just normally go away. So anytime you want to do anything transactional in nature, you're technically doing OLT, operation data workloads. You're technically doing OLT and you probably are working with a database. But if you want to do anything analytical in nature, you do not do it on a database. You do it on something else. I'll get to that. Uh, we are already here. Analytical data workloads. If you want to run analytics, then what do you do? First of all, analytics are best served on summarization of data. First of all, databases may have tons and tons of columns and rows and records, and they are getting updated pretty frequently, right? Pretty much every second, every minute, or whatever. They're getting updated. They're getting updated real time. While most of the reports do not need to be updated in real time. They can be updated once a day, maybe twice a day. I recently worked on a report that got 6 times a day. Every 2 hours, it kind of ran. Every 4 hour, it kind of ran. Right. So it would run at 6 a.m., it would run at 10, then it would run at 2, then it would run at 6 p.m. again. And keeps on going, right? Every 4 hours it used to run. So the thing is, even the most important of the reports that might seem urgent to you, they do not need to be real time in nature. They can be a little delay, right? They can be 2 hours out. They can be like 1.5 hour out. Even if you want to see, so think, what if you want to see real time data? There, I'll get to that in a second. The thing is, what you do is that from the databases, operational data, important data for you is extracted, transformed, and loaded into a data lake. This is a lake right here in step number 2. These are the DBs, right? Right. And from whatever data is important to you via an ETL process, extract, transform, and load process. So data is transformed, whatever is important is kept inside of a lake. From a lake, data is loaded into schema of tables, typically in Spark-based data lakehouse. With tabular abstraction, you can create cubes from that, right? Or within a data warehouse. And on that data, this is basically a summary. This is not all of your data, correct? This is just summarization of data. So from the lake, technically, you're making a summary of data. And from that summary, you are building reports. So if you're building reports out of a summary, the summary would have the most important information needed to build the report. You need not go and like create a report directly from a database. Doesn't make any sense, right? Data in tables may be aggregated, loaded into an online analytical platform, a processing model, or OLAP model. This model is called OLAP model, or this model is called a cube. We call it cubes. Most of the places I worked with, we call it cubes. What do you guys call it? Do you call it like the OLAP models, or do you call it the cubes? Like this model from where Power BI reports are getting generated. Do you call it cubes or do you call them OLAP models? So usually we call them cubes. Like there are different places, different kind of waves. Like you can call them, or depending upon like how you're designing it. Like there's a Power BI activity as well, which helps you do that. But yeah, that's for a different discussion. So the files in the data lake, relational tables, and analytic models can be queried to produce reports, and dashboards can be created directly. But you're doing the model, and this model needs to be refreshed. Anybody who's not aware of this model needs to be refreshed. Pardon my handwriting here. This model needs to be refreshed. Now it can be every 2 hours, it can be every 5 hours, but once it refreshes, it takes a couple of hours or whatever, depending upon the size of it, and then the data comes in. With the refresh, you have the technically the most recent data in the cube. If the cube's data is about 2, 3, 4 hours old, of course the report is going to show the same data. That's why we are saying that reporting and dashboards are mostly not real time. Sometimes they are, sometimes they are. If it's a very tiny report, it's okay. You can just chuck it to the database and it works, right? If it's something that's big and that's detailed, you better have a model for that. Okay. Okay. How is data in relational table organized? Rows and columns, header and footer. This is not a question even. Which of the following is an example of unstructured data? Audio and video files, 100%. Now, this is the question I would want you guys to answer. What is a data warehouse? A non-relational database optimized for read and write, a relational database optimized for read operation, or storage location for unstructured data files. What's It's also too simple.
True. Yeah.
Yeah, life is easy with these questions, right? These are basics. Now, the thing is, data roles and services, right? Now, who are data administrators? Who are data engineers? Who are data analysts? You guys know better than anybody else. We are in this space. We do not need to go this through this, right? Now, this is something I wanted to discuss. Microsoft Cloud Services for data. It's very important, and we are going to go deeper into this as well. By the way, it's later, but we are going to go deeper into this. Microsoft Cloud Services for data. First is Azure SQL, family of SQL servers based relational database services. This is a platform as a service, right? It's a platform as a service thing. So rather than creating your own databases, installing SQL on top of it, then creating tables, schemas, everything, and then creating a database out of it, Microsoft says that, hey, just come to Azure, create an Azure SQL database, just put your data inside and start working on it. That's good. Family of SQL based relational database services is Azure SQL Server. So it's PaaS, it's platform as a service. So you do not have to worry about your database, you do not have to worry about software on top of it. You just worry about your data and you just worry about the permissions or roles assigned to the people. So IAM is another thing that you think about. Azure database for open source. Azure SQL is for MS SQL. It's very MS SQL heavy. If you want to do for MySQL, MariaDB, haven't used MariaDB much, but Postgres, then you're going to use Azure database for open source. Also, you have something called as Azure Cosmos DB. It's a non-relational database system. It's highly scalable. It's super fast, highly scalable, pretty much across the globe services there for Cosmos DB. Next thing is Azure storage. Azure storage goes more towards the infrastructure side of things, how things are at the grassroots level, right? So major three types of Azure storages, actually major four types of Azure storages. First of all, any type of storage. If you want to create any type of storage in Microsoft Azure, first thing you need to create is a storage account. You need to create a storage account first. Once a storage account is created, then within that you can create different types of storages. You can, if you want to store SMB type of files, you want to create a file share, quote unquote, you're going to create files. If you want to store any type of unstructured files, you want to store binary large object based files, you're going to create a blob storage, or you're going to create ADLS Gen 2 storage within that. Okay. If you want to create like semi-structured databases, technically you want to create like tabular. To create tables, you can create a table storage as well. It's structured in nature. Or you can create queues as well. Queues are used for application messages and you can create them as well. Service messages, application messages are in queues. So everything, these are like Azure storages and these are created keeping in mind that we want to uh, these are created keeping in mind that we are working mostly at the infrastructure level of things. We are not working at the platform or like highly as Fabric. So it's a level below Fabric technically. Like underneath Fabric, there is blob storage, right? But it's on Microsoft's end of things, so we don't see it. For us, blob storage is on top of Fabric, right? So if that helps you understand. Hierarchical namespace for data lake storage. If you want to create a data lake, ADLS Gen 2, the hierarchical namespace will come in. Then there is software as a service like Microsoft Fabric. Data ingestion, ETL, we have been talking about Fabric for the entire day. It's okay. Platform as a service within Fabric, it's like uh, Azure Synapse Analytics for pipelines, Spark, SQL Data Explorer. Azure Databricks is in there. Azure HD Insight is there. Haven't been using HD Insight much lately, but fair enough. Which role is most likely to use Azure Data Factory to define data pipeline for ETL process? Data engineer, fair enough. Which services would you use as a SaaS solution for data analytics? Anyone? SaaS solution for data analytics. Would you use SQL database, Fabric, or Synapse Analytics? Examination this showed up. What service would you use as a solution for data analytics? You can use Synapse Analytics for data analytics. You can use Fabric for data analytics. But the categorization here is software as a service. Software as a service is Fabric. Fabric is done for you. Everything is there. Synapse is PaaS, platform as a service. So that's why Synapse is not the right answer in this context. However, for data analytics, both of them can be used.